So this is the programming for solving the problem number 5. So the key here is actually the constants that we used from the previous solutions, as well as the F here. It is actually the analytical solutions for the previous problem. So the first portion is we will ask the user for the number of data points, which the known data point, how much data point we have. So from our previous, for our current problem, we have 5 known number of data point. So here we will prompt the user to input the X and Y values for each of the data point. And then we have here, we will ask the user for the interpolation order must be less than or equal to the number of the non-data point minus 1. So then we ask the user to input the X value that we want to evaluate. In our case, from the previous slide, we have 3 X value that we are going to estimate. So here is where we will compute the divided difference of our Newton's interpolations. And then here we employ the Newton interpolations formula up to the chosen order. So here is the error calculations for the Newton divided difference. We also include it into the equation, into the code. So the input here is the firstly is n, the number of non-data point, x, which is the x value of the non-data point, and y, which is the non-value of y. So the order here is actually the order of Newton's interpolation that we want. So we have the choice how high the order that we want, but of course it also depends on the number of non-data point that we have. So x underscore value here is the data point of x that we want to interpolate. So the output that we will have dd in the bracket I and j, which is the divided difference of the data, which will not be shown in the result, but we will use it for the calculations. So and then we have the results, which is the interpolated y value of the x data point that we want, and the ERR, which is the error between the analytical and the theoretical data. So now we will run the code, MATLAB code for the Newton's interpolations. So let's run it. So as you can see here, it is prompting me to enter the number of data points. So we have 5 data points. So the first one is the 2 seconds data point, the 3 seconds data point, 4 seconds data point, 5 seconds data point, 6 seconds data point. So now they are prompting us to enter the y value. So I'm just going to copy it from the slide. For the second data point, and then the third data point, the fourth data point, and finally the fifth data point. So we want to do the fourth order of the interpolations, and then the x value that we want to interpolate, the first one is 2.25 seconds. So as you can see here is the result that we obtained for the x value at 2.25 seconds. And here is the error between. So this is the value, the second x value that we want to interpolate. So this is the result that we get, a very small error. So let's run the simulation for the last time for the time of x, for the x value that we want. So here is the result that we get, as well as the error of the Newton's interpolations method.